What is up, everyone? Welcome in the next lesson of the full-time GoDev program. And today we're going to discuss, in this lesson by the way, we're going to discuss pointers in Golang, a very powerful concept. It can be sometimes confusing, but I will cover the basics and the pros and cons of pointers, right? So without any further ado, let's do this. So I have this simple Go file here, and a main function, very simple. So what is a pointer? Well, basically a pointer is an 8-byte long integer, right? That's what it is. And it points to a memory address. And that's basically the cliche, what you're gonna find on the internet, right? It's an integer, 8-byte long, and it points to a space, a slot in memory, right? That's what it is. But that's basically the cliche, the theoretical explanation of pointers, and you won't, well, it's good to know, but that is not a practical experience, right? So let's do an example to show you. So what I always do in these kinds of things is let's make something like a player, right? We're going to make a player here. It's going to be a structure, and a player is going to have HP, right? HP, and that's going to be an integer, right? The HP, the health of the player. So let's make a function here, and we're going to call this take damage. We're going to make a function take damage, and what's going to happen is that we are going to say the amount of damage the player is going to take, which is going to be an integer, and then we also going to basically put in the player into this function. So we're going to say p or player, and that's going to be the player, right? And what we are going to do is we're going to say fmt println, and we're going to say something like player is taking damage, and we are going to take this amount of damage here, which is amount, right? And then we are going to say that the player HP, right, minus equals is amount, right? That's something like that. What's going on with this FMT? Yes, that's fine. So yeah, cool. And then we are going to print out here. Wait, we're going to say that player is taking damage, new HP is going to be player HP, right? Yeah, that's what it is. So we're going to make this player here is going to be a P. Actually, let's do it for both. We're going to say player is going to be a player, a new player here, right? And we're going to say we're gonna set his HP to 100, right? And then we're gonna call this function. We're gonna say take damage, and we're gonna put in the player here, and we are going to, I don't know, maybe it's just a small shot in the arm, and we're gonna give him 10 damage here, right? So we're gonna run this. Go run main.go. So the player is taking damage, and his initial HP was 100, but it's going to take 10 damage, so the new HP is 90. Hey, no, so far so good, right? No problems, right? But this is in the scope of the function, of the take damage function. So that basically means that if we print here, fmt println, and we are going to print the player here, right? And we're gonna run this again. What do we see? We see that the player is taking damage, new HP is 90, but after the function is completed, the HP is back to 100, right? And let's do print f here, and let's do a percentage plus v. We're also going to say a new line here, right? So we're gonna see it a little bit better. You see, the player HP is 100, although we are taking damage, and that's because this player here, right? This player we initialize. We're gonna put that into a function, and it's going to be passed by value. It's gonna get a copy. So what's gonna happen is that Golang is going to copy this player struct and put this value inside of this function, which basically means inside of this function, right? If player is not a pointer, we are adjusting the copy of the player. not the actual player, right? That's what happens. And you can already see it. Maybe in a game, that's not cool, right? Because we want to take damage. We want to basically modify the player. How do we do that? Well, we can make this player a pointer to a player. It basically means that we are not going to take in the copy of the player. We are going to take the 8-byte long pointer that points to the memory location where player is stored. And Golang will automatically, each time we call on this player, which actually is a pointer, but when we call this, we call a function here. We call a function, or we call a variable. Golang is going to dereference this pointer. That basically means it's going to dereference the pointer, the 8 bytes. It's going to look up where the player is and modify directly into memory. That's what's going to happen, right? So, of course, if you want to take damage here, this player is not a pointer, it's not a reference, it's basically just a player. So, a couple things we can do. We could say end player here, which basically means do not give me the player, but give me the pointer, the reference to the player. And what's going to happen is, if we do this, we're going to see that right now, it's 90, because we modified the memory, right? So we could do it like this, and player, or we could directly initialize this as a pointer to a player, and it's going to work exactly the same, right? You see? That's the thing. So the same thing happens actually with function receivers. And what is a function receiver? I think I already explained this in the beginning of one of the lessons in the beginning. But a function receiver is basically where we say, for example, func, and we are going to say p or player, right? I like to make it short because we're going to say pointer to a player, take damage, amount integer, and we can actually copy the whole shebang inside of here. The only thing we need to change is we're going to say p.hp, and here also p.hp, right? So this is what they call basically a function receiver, right? It's basically a struct that receives a function, and the only thing it does basically, it's exactly the same, right? So this function and this function is exactly the same, right? Because what Golang is going to do, it's basically going to take in this player, right? And it's going to put the player at the first argument inside of here, right? That's basically what it's going to do. And then we have two of the same functions, right? That's the thing. So, and it's exactly the same, right? You could see that this is going to be a player here, right? And if we, instead of doing take damage here, we could say player take damage, and we don't need to specify this player here, we only need to specify the amount. So if we run this, then it's going to work pretty fine. But if we delete this pointer, right? If we delete this pointer, what's going on here, right? And we call it, then PHP is not being modified. Why? Because we are using a copy. Even in these functions, in these function receivers, this player, because you know it will basically be built like the function we had before, this player is just being copied by value, right? There's no reference. So it will work in here, but after this function, we modified the copy, but here we are actually printing out the actual player, which still will be HP of 100, right? That's basically pointers. Let's do it like that, and it's going to work pretty fine. I guess we need to do end player, actually, and then boom, and it's going to be pretty fine. So that's basically pointers. That's why we use them, right? The only reason why you would use there are actually two important reasons why you would use a pointer, right? First of all, if you want to modify state, right? If you have a function here and you want to basically modify the state, you want to modify this HP, you're going to use a pointer. If you're not modifying the state, then there is no need to pass a pointer. Unless, let me drink some coffee, unless Unless, okay, you need to think about this. Let's say player is going to be, I don't know, a lot of data inside of player. Maybe, I don't know, it could be, right, the big data items and all that stuff. And maybe it's like, I don't know, 1 gigabyte of data inside of player, right? 1 gigabyte. That's actually too much, but hey, it's just for a reference, right? So what's going to happen is that each time, let's make this function actually a little bit clearer. I'm going to delete this, just like that. Wait, let's guys, listen. What I'm going to do is I'm going to delete this stuff. Actually, to be honest, we're going to delete the whole shebang, right? You're going to say func do something. What's going on here? Do something with data. You're going to say data is going to be big data. And this function is going to manipulate some data. I don't know. Maybe we're going to manipulate the data inside this function, right? So we're going to say type big data. It's going to be a structure. And inside of this big data is going to be 1 gig GB of memory, right? Fields, right? Big data, coming from a database, coming from a file, whatever, right? So each time we are going to do something with data, this big data thing here, which is 1 gigabyte of memory, and you are going to put this data inside of a function, right? We're going to say, for example, data is going to be big data, right? And then we're going to say do something with data, and we're going to pass in this data. What's going to happen is that this is going to be 1 gigabyte, right? 1 GB. But then what you're going to do, because this is basically just a value, it's going to get copied, right? This is big data here. It's going to get copied. So what's going to happen is it's going to copy one. Man, what's going on here? It's going to be copy 1 gigabyte of data inside of that function, right? And that's actually not performant, right? Because if you call this function, for example, let's do something like for y equals 0 smaller than, let's say, 10,000 times, right? I plus plus, and we're going to do this. What's going to happen is it's going to copy 10,000 times this data into that function. That's bad. So that's also a reason why we want to use pointers, because if we make this a pointer here, right, just like that, if we make this a pointer and we are going to say that this data is going to be pointing to memory, right, it's basically going to just copy 8 bytes, right? 8 bytes of pointer. Yeah, you see? That's also a very good reason why you would use pointers instead of non-pointers, right? So what can be a problem with pointers? Well, let's give another example here. Why pointers could be bad, and you will probably already experience this in your Golang project or not, or maybe you will for sure come across this issue. Let's say type, let's make a server. It's going to be a structure, right? And let's make a player right now. Player is going to be a structure here. Or to be honest, let's make it a little bit simple. Let's make a storage. Let's make a DB. Database. Let's make a database. Struct, right? And we're going to say that in our server, we're going to have a DB, and DB is going to be a pointer to a database, right? And we're going to say S is going to be also a pointer to a server. Why not? And then we're going to basically attach a function to this server. We're going to say S pointer to a server, get users from DB, just like that. And we're going to say return S dot, let's do this, user string. It doesn't really matter, right? We're going to say return S DB user, right? That's what we're going to do. Of course, we can't because we're going to return a string here. So we're going to say s.getDB from user, right? And if we run this, it's very simple, right? We create a server, and then we're going to say get user from DB, right? So what's going to happen is that if we run this, you're going to see runtime error, invalid memory address, or a null pointer dereference, right? So what does it mean, invalid memory address or null pointer dereference, right? It basically means that what is going to happen here is here, right? This s.db, that's the culprit, right? Why? Because db, actually sdb.user, that's the culprit. So what's going to happen is, actually, the whole shebang is the culprit. So what's going to happen is this db is going to be a database. Yeah? A pointer to a database, which is this struct, right? So we know that this is a pointer. So that basically means that db is going to be 8. It's going to be an integer, right? 8 bytes. Actually, it's going to be an, a uint pointer, actually. Uint ptr, right? Something like that, which is basically 8 bytes long, right? 8 bytes longy, right? So that basically means that each time we're going to call s.db, Golang knows that this is a pointer. So what Golang is going to do, Golang is going to dereference the pointer, the db pointer, right? So that basically means that it's going to look up the memory address of that pointer. Right, what's going on? I cannot type anymore. Of that pointer. That's what it's going to do. But did we specify a database in our server? No, we didn't. So basically what's going on is that there is no valid memory address. Because we have none. This is going to be nothing, right? It's going to be nil. You know what I mean? It's nil, it's nothing. We didn't specify, so we cannot find the memory address, so we cannot dereference this pointer to find the location of this DB. And that's why we get a null pointer dereference, right? So we could check that. Actually, we could, a couple of things we can prevent that, but that's why you always need to check your pointers for nil, right? So what's going to happen is that we are going to say DB is going to be an database, right? So we're going to say that this DB is going to be a database. A pointer to this database, a new initialized database. So if we run this, then everything is going to be fine, right? No problem at all. So let's delete this database once again. How can we check that? Well, how can we prevent these nasty errors? Because let's do it again. You can see panic runtime error. We get this small stack trace here, main.go 14. Let's go to line 14 here. Yeah, we get this. It's pointing us here, but what's going on? Nobody knows, right? So a good thing to do is that if you think there is a possibility that your pointer is going to be nil or invalid or something, what you could do is something like that, right? If s.db equals nil, then we could say return, we could panic out ourselves, right? You could say database is not initialized. Database is null, hence is not initialized, right? If you run this, we're going to get this error right now, right? Panic, database is null, hence not initialized. So this gives you a little bit more information on what's going on. Or you could either say return, I don't know, nothing or something, right? And then nothing is going on, right? What's going on here? You see? Boom. Now we don't have any problem anymore because we handled the case that our database is nil, right? So that's something you need to be aware of, that these null pointer dereferences always mean one thing, and that's basically that your pointer is going to be null, right? Your pointer is nil, it's not initialized, it could not find a value or something, it's bad news. And most of the time, it's going to be kind of nasty to debug, so make sure that if you have pointers in your structures, you try to handle them as much as possible if they could be nil, so you're going to save yourself some time debugging, right? Because this program is easy to debug, but if you have a big project with a lot of pointers, it could run into a bad time. So basically, guys, this is actually, you don't need to know more. You don't need to know more. You just need to know why do we use pointers, when do we use pointers, and how to use pointers, and then that stuff, and all the rest. We're going to use pointers a lot, so you're going to see that in the projects, how, what, and when, and it's going to make a lot more sense. But this, in my opinion, is a very easy to grasp idea what pointers are without too much of killing your dopamine levels, right? So that's it. In the next lesson, we're going to cover, it's basically the next is going to be the last lesson of the Golang introduction chapter. After that, we're going to concurrency. So the next lesson is going to be testing in Golang. See you soon. Bye-bye.